Every coal plant, every nuclear reactor, every geothermal station on Earth operates on the same principle. Heat water, make steam, spin a turbine, generate electricity. This theory proposes that the Great Pyramid of Giza was doing exactly this 4,500 years ago. Not symbolically, not metaphorically. A functioning thermodynamic system built from stone, copper, and chemistry. The proposed mechanism. Steam driving a turbine connected to a copper and magnetic or dynamo is functionally identical to the operating principle of every modern thermal power plant. The Egyptians operated extensive copper mining operations in the Sinai Peninsula. They had documented access to magnetite, a naturally magnetic iron ore, and the chemical residue found inside the pyramid corresponds to the byproducts of the same exothermic processes that generate industrial steam today. Every material required was available. Every principle involved is established physics. Here's how it works. Stage 1. The reservoir. The subterranean chamber sits 30 meters below the pyramid, carved into bedrock at the water table. Water erosion in the chamber and lower passages confirms groundwater infiltrated this space. A rough pit is excavated into its floor. This is where the cycle begins. Stage 2. The boiler. Chemical analysis of the pyramid's interior identifies the heat source. Salt deposits on the queen's chamber walls contain calcium sulfate, the direct product of sulfuric acid reacting with limestone. H2SO4 plus calcium carbonate yields calcium sulfate, water, and CO2. This reaction is violently exothermic. Concentrated sulfuric acid dissolving in water boils it instantly at the reaction interface. Modern acid plants generate 1.2 to 1.7 tons of steam per ton of acid produced, operating at 60 to 200 megawatts. Sulfuric acid residue was found in the southern shaft. Ammonium chloride and zinc chloride, a second independent exothermic system, in the northern shaft. Acid introduced to the groundwater through the pit triggers this reaction. The descending passage, sealed with granite plugs, maintains the chamber as a pressure vessel. Stage 3, the riser pipe, the well shaft. A near vertical, rough-hewn channel connecting the subterranean chamber to the base of the Grand Gallery. Its construction is architecturally anomalous as a human passage. But vertical orientation facilitates convection, and rough surfaces do not impede gas flow. Pressurized steam rises through the shaft. Stage 4, the nozzle, the Grand Gallery. 47 meters long, 8.6 meters high. Its corbelled walls step inward progressively, narrowing the cross-section from bottom to top. Per the Venturi principle, gas moving through a constricting channel increases in velocity. This is a 47-meter acceleration nozzle. The angle of 26.5 degrees balances gravitational resistance against upward gas velocity. Scorch marks on the ceiling are consistent with repeated passage of superheated steam. Stage 5, the throttle valve. The antechamber sits between the Grand Gallery and King's Chamber. Its granite walls contain vertical grooves, consistent with tracks for sliding stone or metal gates. Raising or lowering these gates regulates steam flow, controlling volume, pressure, and timing into the conversion chamber. Controlled pulse delivery maintains consistent rotational speed and prevents overpressurization. Stage 6, the generator. The King's Chamber. Constructed entirely of Aswan granite, it contains a single hollowed granite coffer. The coffer is wider than the ascending passage. It was placed during construction before the room was sealed. Its rigid mass makes it an effective vibration dampening housing for a rotating mechanism. Steam directed at a bladed rotor causes it to spin. The rotor, connected to copper windings rotating within a magnetite field, constitutes a dynamo, the simplest possible generator configuration. The Egyptians had both materials. The 5 relieving chambers above, each separated by 50-80-ton granite beams, are structurally excessive for load distribution. For a room housing a spinning mechanism, they're vibration isolation. The coffer is empty. Whatever it housed was removed. A copper and metal turbine assembly would have been the most valuable object in the structure. Stage 7, transmission. 2 shafts extend from the King's Chamber to the pyramid's exterior. The only internal features connecting this room to the outside. Copper conductors carry generated current out. From there, the transmission path continues through infrastructure that is now largely destroyed. Copper wire ran beneath the polished casing stones, fitted to sub-millimeter tolerances, routing current down to the base. The mortuary temple adjacent to the east face served as the first ground level receiving point. An enclosed causeway, a covered stone corridor, ran from the temple downslope to the valley temple at the Nile. This causeway is functionally a cable conduit. The valley temple at the river was the endpoint. Energy distributed to population centers and agricultural infrastructure. The original pyramidion at the apex was described as gold or electrum, excellent electrical conductors. There is also an alternative. The plateau's water-saturated limestone bedrock is electrically conductive. Energy grounded through the subterranean chamber could be extracted at receiver points and other structures, analogous to Tesla's concept of terrestrial power transmission. The absence of surviving copper is consistent with millennia of salvage. The casing stones are stripped, the temples are destroyed, the causeway is dismantled. Copper is valuable. Stage 8, recycling. The Queen's Chamber. Mid-level, with shafts that don't reach the exterior. Salt deposits up to 1 inch thick on the walls and ceiling. Corroded copper fittings in the shafts. This chamber functions as a condenser. Steam condensing here deposits the mineral compounds found on its walls, exactly what we observe. Condensed water returns to the lower system via gravity. A closed loop. The chemistry is real. The thermodynamics work. Every material was available and documented. The structural evidence matches. The chemical residue is exactly what this process would leave behind. We didn't invent the steam engine. We may have reinvented it.